Welcome to this ESCoE workshop on ever-increasing demand for regional statistics, organized with our colleagues at the Fraser of Allender Institute and the ONS. Thank you for joining us. So the COVID pandemic has really brought to the fore the need for measuring what is going on, not just at the national and regional levels, but also at the detailed local area level. And we have increasingly the tools and new data sources necessary and we need to harness these to develop statistics at regional and local area level, ever more granular. And as my colleague Mari Spowage will often argue, and you'll hear from her later, there's also a need to invest in better and more coherent data collection between the nations of the UK. It is, of course, not just COVID that highlights the need for better regional and local statistics. Significant disparities across the UK, across regions, cities, and towns, and continued productivity weakness demand more granular statistics to inform the levelling up agenda. And that is what this workshop is about. We will hear today from statistics users, producers, and researchers about the issues in developing these statistics, demands for these statistics, data gaps, and where we need to go next. So to kick off in this first session this morning, we'll hear from my ESCoE colleague, Stuart McIntyre from Strathclyde, about his work to develop timely regional indicators, and also from another ESCoE colleague, Andrew Aitken from the National Institute of Economic and Social Research. He'll be talking about his work on measuring welfare at a local area level. And I think we have about 20 minutes for each of the papers, and we'll also have some time for questions. I should mention that this is being recorded. There is a Q&A. You should have a Q&A facility in which you can type your question. If you do have any questions, please just write them there, and we will call your name, and you can then ask it yourself when we get to that part of the session. Stuart, please go ahead.
Thank you, Rebecca. Hopefully you can indeed see my screen. Please let me know if not. Thanks to everyone for joining today for this session. Thank you to the organisers for putting it together. It looks like it's going to be a really interesting day. I was asked to talk about the work that myself and my colleagues, so everything I talk about today will be joint work with my colleagues Gary Koop and Aubrey Poon from the University of Strathclyde, and James Mitchell, a colleague at the Federal Reserve Bank of Cleveland since last year, which of course means I need to give the usual Fed disclaimer that anything I say is not to be attributed in any way to the US Federal Reserve System or the Cleveland Federal Reserve Bank. But I was asked today to talk about the work that we've been doing and more broadly at some of the challenges around regional economic data. From the point of view of many users, and indeed, as we kind of collectively refer to policymakers, timeliness of economic data is really key. Knowing what's happening in the economy in a timely fashion is hugely valued by users and policymakers. Alongside that, from the point of view of academics trying to undertake research in economics, as in the macroeconomy, the longer time series of data is really key as well. In the projects that I'm going to talk about today, we've at a regional level addressed both of those challenges, trying to produce more timely economic data, but also trying to extend the time series of data that we have available using econometric and statistical models. In what I talk about today, I'm going to focus on regional output, GDP, GVA, sidestep the distinction between those two at this point, but also briefly talking a bit about some of the work we've done around productivity. So shamelessly throughout this, I will keep referring to what we've done, but there are other colleagues in the field who are engaged in this area as well. So brief overview, I want to talk a bit about some of the background to regional output data in the UK for colleagues that aren't familiar with the current data landscape, but also some of the recent developments by ONS colleagues and the devolved administrations. as I said, I'll flag up some of the work that myself and colleagues have been doing in this area, and then talk about the implications as I see them for regional data and policy, some of our current work in this area, and then identify a small number of future research gaps and opportunities. So to give you a very, very brief background on regional output data in the UK, and I should flag up at the outset, a number of the challenges that I'm going to identify in a UK regional context are shared internationally. If you look at the US state level GDP, it's around the same timescale as the rusty data I'll talk about. When we think about the annual ONS GVA data for the regions, it's to the same timetable as Eurostat produce it or report it for the NUTS1 regions of the EU. So at a high level, and until 2019, we only had for the NUTS1 regions of the UK annual regional output data produced by the ONS at NUTS1 to NUTS3 levels. So these are now referred to as ITL 1 to 3 levels, but the geographies are the same. And these only went back to 97, 98. So this was what was produced by the ONS. And the ONS still produced these data. The current version is up to the end of 2019. There's a typical release delay of just under 1 year. So typically it's the case that in the December following the end of a year, the ONS will publish these annual data. There's some short delays due to COVID in releasing the 2019 data, but that's the typical release pattern. But in addition to what the ONS have done, we also have data from the devolved administrations in Scotland and Northern Ireland. And these data tend to be more timely. So in the Scottish Government's case, we get not only quarterly output data rather than just annual data, but it's also released just under typically 3 months after the end of the quarter to which it relates. So not only higher frequency, quarterly rather than annual, but also more timely. And a similar situation is the case in Northern Ireland, where the Northern Ireland Statistics and Research Agency produce quarterly output data, which is released just over 3 months after the end of the quarter. And that goes back to 2006. In 2019, however, the ONS started producing their own quarterly estimate of regional economic output for the English regions and Wales, which paralleled in a number of ways the developments by the Scottish Government and the Northern Ireland administration. These are available over a shorter time period, so only back to 2012, and these make use of the VAT data, which is now feeding indirectly to the measure of UK GDP as a whole. Now, again, we've seen developments that have increased the frequency. So we now have quarterly data for all the NUTS1 regions of the UK. As I'll flag later on, there are some methodological differences between the way these are produced that can actually be quite important in terms of our understanding of economic performance. But we now have that higher frequency data, but it still is released with a much larger delay than, say, UK data for the UK as a whole. So in the case of these rusty data, these are released around 6 months after the end of the quarter to which they relate. The rusty data for Scotland and Northern Ireland are the data from the devolved administrations. The ONS's data cover the 9 English regions and Wales. So that's a bit of a just primer on the data landscape, both now and as it was. Because when we began this project back in 2017, we were confronted with a landscape in which we only had, for the English regions and Wales, well, Wales was slightly different, but for the English regions, we only had annual regional data and only from the late 1990s. It was released with a delay of around a year. And our challenge really was to think about improving the timeliness of those regional data. So how could we get more timely measures of what was happening in these regions? How could we improve the frequency of the data that were released? So could we create quarterly measures rather than just annual measures? And because of the importance of historical coverage for many macroeconomic analysis, we wanted to see whether or not we could try to extend the historical coverage of the available regional output data. And of course, at the same time, in our minds, we very much we wanted to make sure that the data were consistent with what was being published by the ONS in the first instance, and ultimately, as I'll talk about, by the devolved administrations and the new ONS rusty data. So we set about building an econometric model that would enable us to model higher frequency. So our goal was quarterly regional output data in the UK and produce more timely estimates of it. So we refer to these as nowcasts. And I'll talk shortly about the way in which we went about the timing of that process. I'm not going to go into the technical details around the modelling. I'm conscious that some colleagues in the call will be familiar with these models, others not. For those who are familiar with the macroeconometric models, what we're using in all these papers is a mixed frequency Bayesian vector autoregressive model. We are dealing with the two frequencies. We've got annual data, we've got quarterly data, that's our mixed frequency dimension, and we impose a number of model features that allow us to better capture the characteristics of the underlying data, and I'll talk about what those are over the next couple of slides. So our initial goal was really to address these through focusing in on the ITL1 or NUTS1 regions of the UK. As I'll talk about later, we're working just now to try to extend this work to the ITL2 or old NUTS2 regions of the UK. That's very much work in progress just now. And the real challenge there for us as researchers is expanding the model dimensions to take into account the much larger number of regions you've got at the NUTS2 level compared to the NUTS1. That presents a number of computational and econometric challenges that we need to wrestle with. So the first piece of work we did in this area, and this is a piece of work that we've relied upon in producing our regular public nowcast that we've published on the ESCoE website since, I think, November of 2018. I think I've got the timing on that right. Every quarter we produced an update after the release of UK GDP and essentially answered the question, given that the ONS have reported that UK GDP growth was 0.5, what does that imply about growth across the UK using our model? That was really the challenge we were trying to tackle in our public nowcast. So our first attempt at doing this was published in this paper in Journal of Applied Econometrics in 2020. And in essence, we're taking the annual regional data from the ONS. That's the sole regional data input at this point, because when we started this work, we didn't have the rusty data from the ONS for the English regions that we could make use of. So this first paper is very much just taking the annual data from the ONS for the regions alongside the quarterly data we had for the UK as a whole, some additional macro predictors. And as I noted earlier, within the model, we made sure to reflect some of the key features of this sort of regional data landscape. So the first was, of course, the release timings and the fact that regional data is released with a much more significant lag than annual data than UK-wide data. Similarly, we also reflected the fact that the observed UK numbers, the observed UK data, reflected the aggregation of growth across the regions of the UK. So we called this the cross-sectional constraint. In other words, whatever our estimates were of regional growth, these aggregated to what the ONS said UK growth was. And of course, because we didn't have quarterly regional output data, we had to model these, but we made sure that when we modeled these were consistent with the published annual data that the ONS publish for the regions. But of course, again, there's a missing data challenge because we don't observe these quarterly regional output data, or didn't, certainly in this paper, and even in the second paper, we don't observe them over the whole period. So then we went through and have a look at the paper if you're interested. We undertook a number of empirical analysis, including a real-time Nowcast evaluation to evaluate whether or not how accurate our Nowcasts were. We looked at regional business cycle dynamics, which, given we didn't have at that point any quarterly regional data in the UK, our model enabled us to undertake new business cycle analysis that hadn't really been possible with the annual data. And it allowed us also to look at issues around economic connectedness between regions. In a follow-up paper, which was published in the National Institute Economic Review at the tail end of last year, we took that model from phase one of the ESCoE project, and we incorporated these new quarterly rusty data from the ONS for the English regions and Wales, as well as the quarterly data we had from Scottish Government and NISRA for these devolved administrations. And incorporating these new data within our model, again, these data were only observed over a subsection of the whole period we were interested in, because we were modelling the longest time span we could, which was from 1967 to the present in growth rates, because we had data at regional level back to 1966. See the paper if you want the details of how we sort of pulled that together. But then what we wanted to do was ask essentially three questions. One was, does this new model with these new quarterly data within it produce more accurate estimates of regional economic growth than the original model? Secondly, could we then use this model to explore the evolution of UK productivity at a regional level? And third, did the inclusion of these new quarterly data change our estimates of regional growth over our full sample period back to 1966? In other words, was there some learning that took place within our model in response to the inclusion of these data? And again, I'll leave people to pick up the full paper if they want to look at the full results. I mean, in essence, on those three questions, what we saw was that there was some learning that took place. Our parameter estimates were updated, which updated our historical estimates a little bit, but mostly towards the latter part of the sample rather than in the earlier part of the sample. We looked at, and I'll highlight in a second, what our model suggested about differences in the performance of different regions in terms of labour productivity. And what we saw, particularly when we compared between the ONS and Scottish Government data for Scotland, is there are quite clear differences between the economic narrative that you would conclude from these different data sets. And I'll show you that in a second. And finally, a real-time nowcasting exercise where, thankfully, from the point of view of publication, we saw significant improvements in terms of the accuracy of our nowcast relative to our original model. So very, very briefly, these charts are in the paper, so you can look at these at your leisure. But in essence, this is just a comparison of the historical output estimates that we produced from these two models. So the original model in blue, which was the Journal of Applied Econometrics model, and the follow-up model where we incorporated these new quarterly data. And you can see there are small adjustments in the historical data, but more substantial adjustments in the later part of the sample. But these are kind of largest for Northern Ireland and Scotland, which given that these data are constructed in a different way to the ONS quarterly data and the ONS annual data, is probably not a surprise. So I'll skip over this because, as I said, these are in the paper if anyone's interested. But the key thing for us coming out of this was when we started to then try and use these data to explore issues around regional productivity in the UK. You can see, and this is also reflective in the ONS data, the quite big differences in performance over the period since 1997 in terms of productivity growth across the different regions of the UK. So Northern Ireland, much worse productivity performance than even the UK, and Scotland, on the basis of the ONS data, very much leading the field here. But one of the things that we were very conscious of is that if you look at the underlying data, the ONS and Scottish Government's data here tell slightly different stories. If you look at the Scottish Government's real-term data and the ONS's real-term data for Scotland, there are differences between them. And what we were interested in as we were approaching this was when we incorporate the Scottish Government data within our model, and so our model has not just the ONS annual data for Scotland, but also the Scottish Government's data, how does that then compare, that sort of reconciled framework, how does that compare to the Scottish Government's data? And in essence, as you can see here, the ONS-based measure, which incorporates both the ONS's annual data, but also the Scottish Government's quarterly data within our model and reconciles that with respect to data for the UK as a whole, suggests far quicker and more substantial improvements in labour productivity in Scotland than the Scottish Government's measure. Now, if you see down here, we've got the ONS's measure of hours worked and the Scottish Government's measure of hours worked. These are basically the same. There are small differences here because the Scottish Government undertake, I think, some smoothing of the series, but basically these are the same. What's driving these differences is differences in the measurement of economic output in Scotland by the Scottish Government and the ONS. And this partly reflects methodological differences, but really what's driving this, as we show in the paper, is the approach to deflation and the way in which regional output is deflated in Scotland by the ONS versus the Scottish Government. And that's a point I'll return to. And again, within the paper, we present the real-time nowcasting exercise, where we show that this second model produces more accurate estimates of regional economic growth across the UK than our original model. But given time, I won't linger on that point. So I highlighted earlier three key issues with the data landscape at a regional level in the UK. First was timeliness, second was frequency and historical coverage, and the third was this consistency of different output estimates. Everything we've been doing so far, I think, helps address the challenges in 1 and 2. And in our second piece of work, we try to reconcile these different estimates. I think we're helping a bit with that third point as well. And this is, of course, really key as we try to understand what's happening in these regional economies. And the development by the ONS and indeed by the devolved administrations in more timely and higher frequency economic statistics is fantastic and should really be encouraged. But with these developments, there are some other issues and tensions that emerge, particularly in terms of the consistency of these, which is a point I'll return to shortly. So what are we working on just now in this area? Well, the first thing we're working on is to take the historical time series of productivity data back before where we currently are. At the moment, we're only 1997 onwards. So we're working just now to take that back to the 1970s so that we can look at longer term issues in UK productivity performance. So that will be out hopefully later this year, that paper. Secondly, we're moving on to phase 3 of our ESCoE project. And phase 3 is essentially to take the models that we've already developed at a NUTS 1 or ITL 1 level and extend those to produce more disaggregated estimates of regional growth. So taking these down to ITL 2 regions. And from a technical point of view, the real challenge here is that we're vastly increasing the model space. We go from 12 regions to 40, as well as having additional UK variables in the model, and that produces computational challenges that we're currently dealing with. Then, and this builds on some work that I know Mark Wheel, who's on the call, and colleagues have led, trying to look at ways of using the VAT data, which now ONS colleagues use to feed into UK GDP. We are going to, as part of this project, look to see how we can make greater use of these sorts of data, so the VAT data, but also some of the real-time indicator data, business survey data, which is available, to try to, again, enhance our understanding of the performance of regional economies in the UK. Very, very briefly, conscious Rebecca will guillotine me off shortly, just to highlight, I think, 4 broad areas of development in economic statistics at a regional level in the UK, which I think merit discussion. And I know there's a number of these where there's already ongoing work that colleagues in ONS, the devolved administrations and others are taking forward. And I think we'll hear from some of the people later today who are engaged in some of this work. The first is, of course, reconciling different measures of regional output across the UK. So we now have data from devolved administrations, the ONS. We also have different measures of output from the ONS. They currently produce this as a GVAB, a balanced estimate. But I think, you know, trying to get to a set of consistent and reconciled output estimates across the UK would be hugely valuable. And this parallels work that's been done at a national level around the consistency of GDPE and GDPI, and we're doing, the researchers involved in this project are doing some other work around reconciling these different measures of GDP at a national level. And I think there's some research there that might be interesting for people thinking about reconciling regional growth estimates. Secondly, the big issue about regional deflators, as I highlighted earlier, these have not just a quantitative effect in terms of changing our understanding of the path of growth, but also a qualitative effect in our understanding of regional economic performance. I think this is an area where there really could be quite significant opportunities for improvement and gains. It's not straightforward, but I think it is an area where there's quite a big prize to investing in this area. Third, I think a key issue around, if we're trying to understand differences in regional productivity, I think we really do need to get better understanding of the evolution of regional capital stocks in order that we can explore that as a potential driver of differences in regional productivity. And finally, I think there's a huge gain from thinking about increasing sectoral data at regional level. So everything I've talked about in this presentation has been very much focused around aggregate regional output growth, whether that be NUTS 1, NUTS 2. I've not really done anything at a sectoral level, and I think for a number of reasons there are potential gains to be had, both in terms of our understanding of the evolution of regional economies, but also in terms of regional economic forecasting and nowcasting from considering this additional sectoral industrial dimension. So with that, I hand over, I guess, to Rebecca, who's going to chair the discussion. And thank you.
Thank you, Stuart. That was great. Yes, please type your questions in the Q&A. I think really interesting to hear about this work. Also, you're highlighting how you have a different economic narrative from different data sources. That's really important. And I think you said that was down to differences in deflators. But I think that's something that's actually a big issue also in making international comparisons. You know, the different practices for deriving these is very important. And also, I think, you know, your attempts to reconcile and bring in new data sources is also something that speaks to the general direction of travel with trying to incorporate high frequency indicators into economic statistics. So we'll hear from, we have an anonymous attendee asking a question, but actually Marianne Sensier, maybe you could ask a question, because I think your questions are very similar.
Hi, yes, I'd like to ask, how do your Nowcast estimates of the downturn during the coronavirus pandemic compare to the ONS regional GDP release during 2020? Did you compare them?
Yeah, thanks, man. Yeah, so as I mentioned earlier, throughout the period, I think since November 2018, we've been running the model in real time. The timing of that, which I probably could have made clearer, was that upon receipt of the UK numbers for a given quarter, we estimate our model incorporating that UK number. And so essentially around a week after the publication of those UK numbers, we've produced our regional estimates. And they're all on the ESCoE website, and welcome to have a look at them. And alongside these, I've published a blog, and of course, the coronavirus hits, we get the big decrease in UK GDP. The question naturally emerges as to what this is going to do to our model. One of the features of the model which we made sure to have was that, something I mentioned earlier, that the weight, if you think about the weighted aggregation of regional growth, had to constrain to the published UK number. And so actually this sort of modelling approach did very well, because it was able to, or was required to constrain to the published ONS number. Now, if we had run our model in March or April of 2020, we would not have done very well, because we had nothing within our model that was highlighting the fact that we were, right into a pandemic. But as soon as we got that first signal of the contraction in UK aggregate activity and said, what did this mean for the regions? Because of the feature of our model, we had to constrain or we imposed the constraint that our regional growth has to aggregate to the national growth. As soon as we observed that big drop in national growth, our model reflected that. Now, in the blog we did, once we received Q2 UK GDP in 2020, we did a bit of work just to essentially explore different ways of imposing that constraint. But that constraint was really key, because it meant that we had to, as soon as we got that signal from the UK, we were able to say, what does this mean for the regions? And because of that constraint, the regional growth estimates were coherent with that national picture. So we tried different ways of doing it, but in essence, because of that constraint, that set of estimates basically reflected what was happening at national level immediately. But as I said, if we'd done that before receipt of the equivalent UK number, our estimates wouldn't have been very good. But that's the approach we've taken to this, to producing these estimates. So that was a bit of a long answer, Marianne.
Great, thanks. Very interesting paper. Thank you.
Thanks, Marianne.
Can we have a question from Mari Spowage?
It's always fun when your colleagues ask questions. Oh. Yep.
Mari, can you unmute yourself? There you go.
Yeah. Can you hear me now?
We can, yes.
Yeah. Yeah, I was just interested in what you said about deflators, and you and I have had many discussions about deflators, but I mean, has there been any work done, as far as you're aware, about how much the difference between the Rusties and the other devolved administration produced statistics are caused by deflators, and how much are from different underlying data, like on construction? I mean, I think it would be quite good if there was something that could be researched jointly, perhaps between ONS and the DAs, and something could be published on it, because I think it's quite an interesting question.
Yeah, no, I think it's a good point, and while it's probably not of sort of wider interest to normal folk, I think it is a key thing for those of us that are working with these data in this sort of way, because I attributed much of the difference here to differences in deflators, because if you look at the data on a nominal terms basis, they're very, very similar. I mean, we have that in the National Institute paper. If you compare these output estimates on a nominal basis, they're very, very similar. But there have been a number, as I know you know, but there'd be a number of differences in approach the Scottish Government, for example, have taken compared to the ONS that have reflected experience that they've had of capturing developments in the Scottish economy, and in particular, I mean, there was a whole thing about the measuring output in the construction sector, which I know is a challenging area anyway. So there have been these methodological developments. I will leave it to statisticians and those with experience of constructing GDP to talk about what might be done in terms of setting out and quantifying the contribution of these different methodological decisions and choices. But it would be an interesting thing from my point of view for us to know a bit more about the impact of some of these methodological differences. But certainly the first order driver from my point of view is very much differences in deflation.
Yeah, thanks, Stuart. I mean, it's just fundamental to understanding how growth is evolving in different regions. So I think it's more than just of interest to geeks like us. But,
I think people will be I think there's a more general interest in, well, wait a minute, these numbers tell us slightly different things. And in the case that I highlighted earlier, quite big differences. And I think, helping users understand that's quite important. But, the underlying investigation of that's probably not of more general interest, but the explanation for those differences is, I guess, would be my take on it.
Okay, so we're running out of time, but I would like to take two more questions from Christian Spence and then Margaret McAvoy. Please, if you could ask your question relatively succinctly, and also Stuart, if you could provide a relatively short answer. So, thank you.
No, I'm noted for that.
Christian.
Hi, thank you very much. Excellent presentation, thank you. There's been a huge amount of work done over the last year or two with papers like yours, deriving greater granularity in regional stats from sort of increased complexity of econometric modelling techniques. To what extent do you think in the future we're going to continue relying on econometric modelling to derive regional data, or do you think we will have greater opportunity to start to devise bottom-up administrative or other data methodologies to actually aggregate from small geographies to the nation as a whole?
Thanks, Christian. It's a really good question. I don't think it's neither or, if I'm being honest, because I think part of the challenge is that when we get more granular data, so take, for example, the VAT data that we're talking about, we've got that as a signal alongside other signals about what's happening in regional economies. And unless we are going to do for each of the regions what, say, the Scottish Government do for Scotland, which is really invest in constructing that sort of really bottom-up type estimate, and measures of GDP are not perfect by any means, and there's always methodological improvements, but absent that, I think we need some sort of framework to reconcile these different signals. And inevitably, I think econometric frameworks that allow us to impose very transparent constraints within them enable us to produce those more timely estimates that reconcile these different signals. And I think, unless we're going to put the huge investment into bottom-up estimates, we're going to need these sorts of econometric models to enable us to generate and reconcile these different signals that we've got. I don't think it's either or. These should be complementary.
Thank you, Stuart.
I can. Yeah.
You want me to come in?
Yes.
Yeah. Thank you very much, Stuart. A really good presentation. Very interesting. My question follows on, I think, from Christian's, but it's about sources of data. You mentioned VAT, VAT as one of the sources that you use, but could you list some of the other sources that you use for the nowcasting?
So within our nowcasting model, the core model is the data, or the core database is data produced by the ONS in terms of UK GDP, the rusty data, quarterly frequency for the regions, the GDP data from the devolved administrations. Of course, in turn, they reflect the aggregation and reconciliation of lots of other data signals. We've explored within our framework, including a range of other regional data, so business survey data, so from CBI, labour market data, but actually it's in some work we are in the paper that we are working on right now. We quantify the importance of additional regional data versus other features of the model, and perhaps not surprisingly, given our setup, the most important thing for the accuracy of our estimates actually isn't more regional data. It's the first order thing is the constraint that we have between regional growth and UK growth. That's adding a lot of information to our information set compared to adding additional regional data, which we tend to find doesn't really improve our nowcasts much beyond that cross-sectional constraint. So in other words, the signal we get about the UK economy is of first order importance compared to some of these other signals.
Thank you. I think we better move on to Andrew's paper. Thanks very much for your questions and also your answers, Stuart. That's really good. So Andrew Aitken, you're going to talk about welfare.
Thanks, Rebecca. Okay, so this paper is called Welfare Indicators for Lower Tier Local Authorities in England and Wales in 2016, and this is joint work with Martin Wheel. So apologies to Northern Ireland and Scotland, but the reason they're not in there is because of data limitations. So the usual disclaimer from ONS, and also a further one from us that this work is quite preliminary and is incomplete. So the motivation for this paper is that there's obviously, I mean, it's generally, I think people will be familiar with the fact that GDP is not a very good measure of welfare. It's not designed to be. And of course, there's many factors that affect people's welfare other than income, such as health, life expectancy, environmental conditions, things like that. And so particularly since 2009, since the Stiglitz-Sen-Fitoussi Commission report, there's been a lot of effort put into devising alternative measures of welfare. And there's been different approaches to do this. So one approach has been to have a dashboard of measures. So for example, the ONS publishes a large dashboard of different measures. The OECD also has a dashboard as well. The alternative approach is to construct a composite measure. And this is something that there are a number of examples of. For example, the Human Development Index. And there's a variety of other indexes and things floating around out there. What we're producing here is based on a paper by Jones and Klenow from 2016. The only difference is that we're focused just on England and Wales, whereas they were looking across countries across the world. And so we're producing a welfare metric based on their approach, which takes into account life expectancy, consumption inequality, and leisure. And this is in a standard expected utility framework. So it's fairly parsimonious metric, but it's basically using standard tools of economics. And for example, Martin Ravellian in 2012 paper criticised what he called mashup indices, such as the HDI, which tend to just lump together all sorts of different things without really much theory as to how it all works. So as I said, we've got a standard expected utility framework, utility function here, where each adult has utility function defined over consumption. And so we follow very closely what Jones and Klenau do. There are a few differences here and there, which I'll try and remember to point out. So one of these is that we separate consumption into private and public consumption. And of course, people also derive utility from leisure. And then people's health status affects the utility that they get from consumption and leisure. From the simple fact that if people are obviously not well, then they might not be able to enjoy the same returns, if you like, from the consumption that a healthy person would, or they might be spending money to try and or doing things differently in terms of consumption and leisure to make up for the fact that their health is not so good. So we consider two different health statuses. Good, so health status equal to 1, and poor health status equal to 0.8. So that's the HT in this utility function. And then the very first term inside the curly brackets here is U bar, which essentially reflects, and this is equal to 5. So this is essentially saying that the value of a life for a 40-year-old is equal to the value of the remainder of a 40-year-old's life is equal to about 5 million. And we're largely following measures here from Jones and Klenau. And so Jones and Klenau also don't distinguish between poor and good health. And then we also have theta, which is the utility weight on leisure. So we're using a 14.2 here, which comes from Jones and Klenau. This comes from US data. This is something that we need to have another look at, but this is basically derived from the first order condition for the marginal rate of substitution between consumption and leisure is equal to the wage rate, or the after-tax wage rate. So that's where that's derived from. And then we've also got the fresh elasticity of labour supply, the elasticity of labour supply with respect to the wage rate, holding the marginal utility of consumption constant. And we're setting this equal to 1 following Jones and Klenau. So we can, and the other important point to mention is that we're taking into account inequality in consumption, because we have here the mean of log consumption, and this is essentially the geometric mean, or equivalently, it's the Atkinson inequality aversion. It's the Atkinson inequality, a measure with the aversion parameter equal to 1. So in other words, this is what you would have if everyone was given equal weight. So this is very similar to what Jones and Klenau do. So the previous utility function can be extended into a lifetime utility function. So here we've now got a discount rate, which is beta, which we set equal to 1, same as Jones and Klenau. And then we have rho t, which is the probability of surviving t years into adulthood. And as with Jones and Klenau, we're assuming that the future consumption of a young adult is simply equal to the consumption of an older adult with a growth rate g applied to it. And we're assuming that there isn't any change in labour force participation or unemployment over time. And we're also assuming that private and public consumption grow at the same rate, and that consumption is log normally distributed. So we could evaluate this measure, and we are working on evaluating this measure. We could evaluate this if we had data on survival rates and on the prevalence of good health, which we didn't have, but we now do. So we are working on estimating this measure. But what we've done so far is to estimate a slightly simpler measure, which just uses life expectancy in good health, life expectancy, and healthy life expectancy. And a couple of the other parameters here, health status I've already mentioned, and the share of private consumption, this is alpha, and this is equal to 0.79 private consumption, so public consumption 0.21. So what we're doing here for both this utility function and in the previous one is we're weighting the mean of log consumption. We're weighting this by life expectancy or survival rates multiplied by the prevalence of good health. And we're doing this for different age bands and adding these up. So turning to the data that we're using the Living Costs and Food Survey, the LCFS from ONS. So this is a household survey of about 5,000 households, except we're using, so this includes a record of people's expenditure, but the data we're using has been provided to us by ONS, and this is the expenditure data scaled up so that it matches the national accounts. And we have data for about 278 of 332 local tier local authorities, but often the coverage in these is quite small. So we often only have one household in an LTLA, and then there are about 55, I think from memory, LTLAs where we don't have any data at all. For hours worked, we're using this to construct a measure of leisure time. It's obviously a fairly crude measure of leisure times that we backed out from, total of hours in the day, and subtracting people's hours of work from that, as there aren't any other time series estimates of leisure time for the UK. And as I've already mentioned, we're using estimates of healthy life expectancy and also total life expectancy. And we have these for UTLAs, and we're simply applying these to the relevant LTLA in each UTLA. And we now have UTLA specific survival rates, and we also have data on the prevalence of good health. So this has about 5 different categories of health status, and we take a person to have good health if they're in one of the first 2 categories. And then we're also using ONS data on public sector expenditure. So we're constructing a measure for each individual of the consumption that they get from education and health, largely. So the other issue we face in doing this is the lack of consumption data and also leisure time data at small areas, in local tier local authorities. So we're doing some small area estimation to produce small area estimates of both consumption and leisure time. So this is somewhat similar to work that the ONS does in estimating small area estimates of income, for example. So the data we're using for this is log average electricity consumption, log average house price, and the average of log income. And this is household equivalized income. It's the sum of income that's subject to PAYE tax, and added onto this is any benefit income. So we don't have self-employed people in here. And the data that we have is by decile, so we use the means of the logs to approximate the mean of log income. So this is population level data, and this is the constraint that we have at the moment. So we only have this data for 1 year, 2016, and we only have this data for England and Wales. So when we first started this project, we were expecting to, or hoping to, do a time series, estimate a time series, but at the moment we only have 1 year of data. So just turning briefly to the small area estimation. We're using a mixed effects model, so we're We've got a fixed part, which is house prices, electricity, and income. And then we're modeling a random part. So so we're modeling here Y on the left-hand side is either consumption or leisure time, and we're estimating leisure time separately for men and women. And when then the random component in this linear mixed model is we're modeling age bands, government office regions, and the LTLAs. So this reflects the fact that the consumption data and the leisure time data or working time data that we have is often quite sparse in each area, in each LTLA. And so that's why we're using the random effects there to reflect that. So this gives us estimates for beta and also estimates of the variance for the age bands, the government office regions, and the LTLAs. So this is just the results for consumption in the first column here, and then the results for working time for men and work input for women. So you can see that income, electricity use, and house prices do quite a good job in terms of their relevance. In terms of the random effects, we will probably leave out regions when we next come to estimate this model, as it's not really significant. So after we produce these small area estimates of consumption and leisure time, we then go back to our utility functions that I've shown you. And as I said, we're constructing these measures by weighting consumption, mean of log consumption, weighting that by life expectancy. And we're doing the same thing for leisure time. And so we can produce estimates for men and women separately, which is what I have here. Or of course we could average these and just produce a single measure. And we've also done this separately using the difference where we take into account the healthy life expectancy versus just using the total life expectancy. And the overall results, the results are quite similar. The correlation between those two is quite high. These results here take into account using the healthy life expectancy as well as the total life expectancy. So another issue that we currently face is that these results are incomplete. So we have to drop 96 out of the 332 LTLAs due to ONS disclosure rules. And so we're still discussing with the ONS as to whether we might be able to export all of the results, given that it's not possible to recover the mean of the observations, even knowing the fixed effect estimates and the variances of the random components. So bearing in mind that these results are somewhat incomplete, I mean, looking at what we have here in the top 10 and bottom 10, you can see it's largely Buckinghamshire, Surrey, and surrounds that appear in the top 10. One perhaps interesting thing is Manchester is really near the bottom, which is perhaps a little bit surprising. So in terms of future work, as I've already mentioned, we're still working on whether we can export all of the results. We also want to do some decompositions, so we can try and decompose the effects on people's welfare from the different components. So what effect does consumption inequality, leisure time, and life expectancy have on people's welfare? So that's the work that's still to be done. And then we also need to do a little bit more work on some of the key parameters, as I've already mentioned. So we're currently using some parameters based on US data. So we also need to look at that, and we could investigate a little bit more the sensitivity to the results from some of those parameters. We could also explore different functional forms for the utility function. For example, we could consider the effects of a non-separable utility function, for example. So that's it. Thank you very much.
Thank you, Andrew. If anyone has, I think we have time for a question or two. If anyone has any, please type them in the Q&A. We don't have any at the moment. Really interesting work, Andrew. I'm a little bit surprised about the disclosure issue. Presumably these are estimates based on a model with many more observations. So I hope that you are successful in releasing these figures. It would also be interesting, I think, to see once you've done all this work, if you're able to compare to estimates of local area GVA, maybe constructed from some of the microdata. That would also be interesting, because there's always that discussion about how well GDP or GVA does in terms of capturing welfare. So that would also be interesting to see. So if we have no further questions, it's now, we have.
Martin's got his hand up.
Okay. Martin and then Ed Humphreys.
Hello, I just want to thank you very much, Andrew. I hope other people found it as interesting as we have. On the issue of disclosure, I just wondered whether I could explain what it is. The SRS won't allow release of aggregates computed with fewer than 10 observations, and obviously in some of our LTLAs we do have fewer than 10 observations from the LCFS underlying the data. But as you observed, Rebecca, actually what we're producing are composite estimates, not the means of these 10 observations in any shape or form. And so, we do hope that and I think are reasonably optimistic that in preparing the final paper, it will be possible to release figures for all LTLAs.
Thank you, Martin. So we have a question from Ed Humphreys who doesn't have audio, so I'll read that out, and then we'll go to a question from Tony Price. So Ed Humphreys is asking how your results compare to indices of multiple deprivation and also to personal well-being measures published by ONS.
Yeah, I mean, similar to what Rebecca was suggesting about comparing to GVA. So this is something that we could definitely do to compare the results to the IMD and the personal well-being. Yeah.
Tony Price, would you like to ask your question?
Yeah. Hi, thanks. That was really interesting. I was interested that you said that you were using public expenditure at some disaggregated level. I'm quite interested in knowing what the disaggregated level is and what the source is. I know in central government we're having quite a lot of trouble trying to work out where public expenditure is occurring.
Okay, Martin might want to come in on this one because he did the calculations for this, but I think it's country and regional public sector fiscal year tables. So it just takes total current expenditure. I think we deduct debt, interest, social protection expenditure, EU transactions, and then we simply allocate that. I say simply, we allocate that to so that gives a figure for total consumption, which then we allocate to adults in England and Wales.
But sorry, how do you allocate that at you said regionally? Is that right?
Martin, do you want to say more on that? I think it's regional tables.
Oh, sorry. I mean, could I say a bit more on this, because no, the LCFS, or rather the ETB data source, allocates some forms of public consumption to households, and therefore one can infer presumably regional patterns of consumption from that, at least to some extent. I mean, they may show that in Worthing you have high public consumption of health services because the population is in Worthing is older than, say, in some parts of London. But what it may not show is whether, given that there's a particular bias towards Worthing or indeed away from Worthing. But no, we actually have taken what at the moment, something of a shortcut. There is, I think, a real issue about how you treat health spending. Do people who make high use of the National Health Service get a higher level of welfare than people who make low use of it? You might hope that if the NHS is optimally allocated, then all it's doing is making up for other welfare reducing effects. So in terms of a welfare measure, our conclusion was that we should allocate health spending equally on a per adult basis, and assume that actually if people get more than average, it's simply compensating them for the fact that their health is worse than average. So for a welfare measure, you don't want to reflect that. In terms of education, there is more we could do on the allocation. We have in the short term simply assumed that each adult gets a constant amount, gets a uniform amount of public spending. So I appreciate that that is a shortcut, and it certainly doesn't answer your question.
Thank you, very interesting.
Okay, well, thank you very much to both of the presenters and for your questions and for the answers. Really interesting work. You can go and grab a coffee now, and please join us again at 11 o'clock for Regional Impacts of COVID-19, The View from Academia with Mari Spowage, Marianne Sensia, and Raquel Ortega Arguelles. Thank you very much.